A NAS is optimized to store data. In many cases, the NAS is even the only storage location for personal files. Depending on your individual needs, you can use the hard drives in our Synology NAS standalone, separate from each other, or in a shared hard drive array with or without failover. In addition to selecting the appropriate NAS and hard drives, it is just as important to decide how we want to use the hard drives in our system. Synology systems offer a variety of ways to configure hard drives to meet specific usage requirements. Hard disks can run individually, separately from each other, but can also be switched to a hard disk network. Depending on your personal requirements, you will then decide on a suitable hard disk array, each of which brings with it certain characteristics. We will look at which these are later on. When talking about hard disk array, we usually refer to it as a RAID. RAID is the abbreviation for redundant array of independent disks. Simply said, in a classic RAID, the hard disks work together in a group and offer us, depending on the type of RAID, more storage space, performance, or an increased reliability of hard disks. The so-called RAID controller takes over the management of the hard disks and data. The controller works in the background, so there is nothing for the user to do except to select the desired RAID type. Synology systems use a software RAID here. This means that the RAID is controlled and managed by software and no additional hardware RAID controller is installed. This brings a big advantage in compatibility. With software RAID, we can easily move from a small or old Synology system to a new or larger Synology system. By simply plugging in the hard drives, we can migrate the entire old system with all data and settings to a new system in a few steps. Let's look at the different uses of hard disks in detail and start with the use of individual hard disks without bonding. Individual hard disks, bases. As a small example, we see here 4 hard drives of 4 terabyte storage capacity. Now, if we were to take these disks one at a time, so we wouldn't use it in a hard disk array, we would have the full capacity at our disposal. A total of 4 times 4 equals 16 terabyte. And we would have 4 individual separate storage areas, so-called volumes, on which we could store our data. This means that the data is always stored on a specific hard disk and we don't have any contact points of the individual hard disks or data that is stored on them. This means that we have to keep an eye on the used memory of each hard disk, and if necessary, we have to copy data or store it on one of the other hard disks if the disk is full. If, for example, our photo and video folder should fill up hard disk number 1 over time, we would have to store further data on the other hard disks, such as hard disk number 2 or 4. In case of a hard disk failure, here, hard disk number 1, we would lose the data of the respective hard disk in any case. Fail safety, redundancy, is therefore not given here. Composite without failure protection. In addition to using single HDDs, we can also use a hard disk array, as already mentioned. Here, Synology offers 2 arrays that do not have any failure protection but offer full storage capacity. JBOD is abbreviation that stands for just a bunch of disks. Here, like in the Basic, each hard disk works on its own, but the hard disks are connected in series and are made available to us as one large storage space. We need 2 hard disks to create JBOD. The system automatically stores our data on the hard drives one by one, If hard disk number 1 doesn't have any more space, the next data is stored on hard disk number 2 and later on hard disk number 3, number 4, and so on. The system doesn't offer us any protection in case of a hard disk failure. The data on the respective hard disk is then lost in any case. The available capacity is the sum of the hard disk capacities used. And we can add more HDDs to expand our storage space as needed. Simply put, JBOD corresponds to the use of individual hard drives, except that the system automatically writes data to the next hard drive when there is no more space on the previous hard drive. The second compound is RAID 0. We need 2 hard drives to boot because the file is not stored as a whole on one hard disk, but is split and then distributed to the existing hard disks. As there is no copy of the file, but only a part of the file on each hard disk, all data is lost as soon as one hard disk fails. It also gives us the full capacity of our hard drives. Every hard disk we add expands our storage space. Even if it may seem untypical at the first glance that the system splits and distributes a file, the reason for this procedure is quite simple. The writing and reading of the file is thus distributed over several hard disks and is therefore much faster, and the data through output is increased. The RAID 0 thus offers a very high performance. However, it doesn't offer any reliability if hard disks fail. Let's now move on to the classic hard disk networks with data redundancy. Here we have no data loss if one or more hard drives fail. This is possible because RAID controller distributes recovery information, so-called parities, of each individual hard disk to the other hard disk in the array. If one hard disk fails, we can simply continue working with the system. We can then replace the faulty hard drive with a new one and the RAID will restore the original state. Since the recovery information requires storage space, we do not have the full net capacity of our hard drives available to us with these types of RAIDs. In any case, we advise to always use HDDs of the same capacity in classic RAID systems, since a classic RAID is always based on the smallest HDD. Let's have a look at the characteristics of the individual RAID types. The classic of the RAID is RAID number 1. This is often used in small devices with 2 slots. For this, we need at least 2 hard drives. Then the data is written to both hard drives. You might know it with the term mirroring. We are only allowed to have one failure when using 2 HDDs. We only have capacity of 1 HDD at our disposal. With RAID 1, we cannot subsequently increase the net capacity. Each new hard drive we add only increases the reliability, but not our storage space. So if we already know today that we need more storage space in our RAID network in the future, RAID 1 is not the right choice. RAID 1 is the classic and is often mentioned. However, many don't know that we cannot expand the capacity of this RAID. If we would install 4 hard drives, 3 hard drives could fail without losing memory. Although this is a very high availability, it is usually not desired by the users. For easy failover with the option of storage space expansion, RAID number 5 is the right choice. We need at least 3 hard drives to build the RAID. The RAID stores the actual file but also corresponding recovery information parities on other hard drives. This is technically also called striping. Any hard disk may fail without loss of data. In total, we lose the capacity of one hard disk due to the striping. Every hard drive we add to this RAID increases our storage capacity. Since several hard drives run in a network, we have a higher write and read rate than with a single hard disk or RAID 1. The combination of performance, storage space, and reliability makes RAID number 5 the most used RAID in devices that can hold 6 to 8 hard disks. An even higher redundancy is offered by the RAID 6. We need at least 4 hard drives in comparison to RAID 5. RAID 6 offers an additional striping layer which allows the failure of any 2 HDDs without data loss. Thanks to the additional security, we then work with the device without the capacity of 2 HDDs in total. Each hard disk added increases the storage capacity of our RAID 6. RAID 6 makes sense about all when the focus is on reliability. RAID 6 therefore also offers a higher level of reliability in smaller devices than RAID number 5, but especially in devices with 8, 12 or 16 hard drives, RAID number 6 is the better choice. The more HDDs we use, the higher is the probability that several HDDs will fail at the same time. Let's move on to RAID number 10, the best choice when it comes to performance and where ideally high redundancy is also offered. We need at least 4 hard disks here. RAID number 10 is a mixture of RAID number 1 and RAID 0. Here, 2 hard disks work together as RAID number 1, over which RAID number 0 is placed. So, like in a RAID 0, the file is split and distributed, but not on a single HDD, but on a RAID 1 pair, which increases the reliability compared to RAID 0. Also here the user only sees a large storage space. In order not to suffer any data loss, only one hard disk of each pair may fail. Otherwise, the data in this RAID pair is no longer available. In short, when using 10 HDDs, the RAID 10 can handle a maximum of 5 hard drive failures as long as it don't belong to RAID number 1 pair. Due to the high redundancy, even with RAID number 10, we only have 50% of the total hard drive capacity available. With RAID number 10, we always have to add 2 hard drives to expand the storage capacity. Compared to the other RAID types, we need much more hard drives in RAID number 10 to cover the same memory requirements. Of course, this leads to higher acquisition costs. However, due to its many small RAID 1s, it offers an extremely high performance which is not reached by any of the other mentioned RAID types. RAID 10 is ideal for applications with high input-output requirements, IOPS, for example database servers, so it is quite clear that performance is more important than purchase cost. In addition to these classic RAID types, Synology also has its own RAID types for different needs and user groups. Synology Hybrid RAID, SHR for short, is a popular and convenient RAID for home users and SMBs, as it brings the classic advantages of the known RAID types but offers more flexibility. Synology offers 2 flexible RAID types with the SHR number 1 and SHR number 2 with the failure protection of 1 or 2 hard drives. The SHR number 1 is most used RAID of the two variants and is mainly used by home users and SMBs with systems with up to 8 HDDs. The advantage here lies in 2 points: flexible growth and managing hard disks of different sizes. Let's take a look at the flexible growth first. Suppose we buy a 4-bay device, want to start with 2 HDDs, but also want to expand the memory later by adding HDDs. RAID 1 and RAID 5 could not accommodate these needs. SHR can start with the HDD. Of course, it doesn't offer any protection against failure. When second HDD is added, it behaves like a RAID 1 and one HDD can fail. When the third HDD is added, SHR behaves like a RAID 5 since we have more space, but we can still have one HDD failure. In our 4-bay NAS, we would now have one more slot free to expand our storage space with another HDD later. An additional advantage of the SHR is the handling of HDDs of different sizes. HDDs are getting cheaper and cheaper, and it would be ideal if you could add bigger and cheaper HDDs to your RAID after 2 years. However, classic RAIDs such as RAID number 1, 5, or 6 are always based on the smallest hard disk in the volume. If, for example, a 2 terabyte HDD is already in the volume, the RAID cannot use the additional capacity of 4 terabyte HDD and would only use 2 terabytes of those 4 terabytes. SHR, on the other hand, can, if we always use pairs of the same size, fully utilize the greater capacity and make it available to the user. This happens because a small sub-RAID is being built here. Of course, this happens automatically and the user doesn't have to do anything. The SHR therefore offers great storage growth with the larger HDDs, which we will add to the system later. As we can see from this picture on the Synology website, only the SHR 8 terabyte discussed earlier is available for free. If we had manually selected RAID 5, 4 terabytes would be completely wasted. The very useful tool we can see here is the Synology RAID calculator. It can be accessed directly from the home page and allows us to try different RAID combinations and hard drive configurations in advance. In addition to the flexible SHR for RAID for home and SMB users, Synology also offers solutions for enterprise users. For SSD-only systems, so-called all-flash systems, the classic RAID types are not always the right choice. The classic RAID types are designed for HDDs and always put the same amount of load on the hard drives. However, this even load is not ideal for SSDs, as they have a predefined number of write operations or a very specific amount of data with which they may be written to at most before they will surely break down. Simultaneous load would therefore lead to a prompt failure of all SSDs. Synology's RAID F1 solves this problem with an algorithm that distributes the workload unevenly across the drives. This effectively prevents the probability of a total failure. Here, an important hint for a stable and secure interaction of hard disks within a RAID network. The hard drives within a RAID do not necessarily have to be from the same manufacturer. However, they should be identical in terms of the technical specifications. Different sizes are not a problem, but as we have learned, not always the full storage capacity can be used in mixed operation. The speed plays an important role here. since the RAID performance is also dependent on the slowest disk. Therefore, you should use HDDs that rotates at the same speed. With the sector sizes, we have to pay special attention because here we always have to use the same sector size and should never mix, as you can see on the picture, 512 hard disk with a native 4K hard disk. If we risk this, the probability of a volume crash is high. The more hard drives we use in a system, the higher the probability of a single disk failure, of course. In large business models, especially when we have extensions connected, we use a lot of hard drives, which increases the probability of a failure. In our example, we would have 36 HDDs, of which only 2 are likely to fail. In order to avoid such scenarios, we work with so-called RAID groups in the large models. When creating the RAID, the user is asked how many HDDs should be in a group. This can consist of 6, 12 or 24 HDDs. This means that the device automatically creates a new independent RAID from a user-defined number of installed hard drives to ensure even more reliability. Another feature worth mentioning is the global hot spare hard disk. Here we define one or more HDDs which are not actively used as a storage. And hot spare then means that this predefined HDD immediately jumps into action if a hard disk fails from the RAID and repairs the RAID. So we do not have to be present or manually set something in the DSM. This technology is ideal for environments that are not always supported or accessible. Global means that the hard disk would jump in at every RAID. So for example, if we have 2 separate RAIDs running in one system, we do not necessarily have to define the hot spare for each RAID. The hot spare jumps in RAID independently. As we have seen, there is suitable constellation of hard drives or RAIDs for every application. One must always keep in mind that a RAID is not a backup and therefore cannot replace it. Should the NAS fail completely or suffer damage due to disasters such as fire, water, or overvoltage, our data is not backed up. Therefore, an additional backup to external storage media, another NAS, or to a cloud is always important and can be set up quickly, easily, and automatically with our integrated solutions.